Good morning, everybody, or good afternoon, I should say. Thank you for joining us today and setting aside some time to learn about the history of glass in Toledo. We're very happy today to have Kyle Sword with us presenting on this subject. Kyle is the Business Development Manager for Pilkington North America and heads the company's interests in historic restoration. Kyle has worked for Pilkington for over 15 years, mostly in glass manufacturing. He has a ceramic engineering degree from the Ohio State University and an MBA from California State University, Sacramento. Kyle is involved with a variety of different technological developments in the glass industry. Kyle spreads glass education and looks for new opportunities to provide value for customers, creating products with coated and flat glass products. We're thrilled to have Kyle today giving us this preview, focused on Toledo, which is going to be the site city for our state conference, which will be held on October 3rd to the 5th, 2022, and for which we hope to have registration out by the end of this week. I want to give a quick thanks to the Ohio Arts Council in part for funding our webinar series, and we hope that you will join us again on September 7th for our next webinar, Partners for Sacred Spaces, focusing on helping save or how to adaptively reuse historic churches. So Kyle, thanks so much for being here. If people have questions, you can type them into the chat box and we will get to those at the end of the presentation. So Kyle, thank you so much and take it away.
Awesome. And Devin and Matt, thanks again. Appreciate it. And just making sure you can hear me and see my screen okay, but it sounds like we're in good shape. So again, I'm a manager of business development for NSG Pilkington. I'm going to be talking today about glass history in the glass city. As a lot of you know, Toledo is known as the glass city. A lot of you may not know why Toledo is known as the glass city, so I'll go a little bit about that. And I work, again, for reference, I work in the architectural world. NSG Pilkington used to be called Libbey Owens Ford or Pilkington. We've been here for quite a time, but our primary focus has been the architectural world. We also have serviced quite a bit of automotive as well, but I'm going to mostly concentrate on architectural. Again, here's the description that goes through. I think this was sent out ahead of time, but we're going to talk quite a bit about the rich glass manufacturing history here and all the inventions and creations that have come out of the space. A couple different learning objectives, but essentially what you're going to learn about is the different types of industries here in the town, some of these innovative products and processes. I'll talk a little bit about how these developments have impacted green and sustainable design in buildings. And then I will talk a little bit about some of the emerging technologies that are coming out again today, just to give you a little sense of maybe some of the other things you may not be aware of. So for reference, there's quite a few different great reference books that are here. And while you're here, if you're interested in history, the local libraries, there's one in Rossford and there's a couple here in Toledo. There's one downtown catty corner from my office. I go talk to the people there at the libraries all the time, really great reference resources. But the three main books that I would say is The Glassmakers Talks About Pilkington. This again references some of our company history over in Europe as it was developed. But the two local ones are going to be called Fire and Sand and The Roots Grow Deep. And those are primarily about the developments in the Toledo area, but a lot of the glass industry as well. There's a couple charts here. Milton Knight is a friend of ours. He's a great grandson of Edward Ford, I believe. And he's got these two slides on here. I won't go into these in great detail. There's so much information here, but essentially if you go back through these two slides, this links all of the different types of glass companies that are in the Toledo area, how they started, who those people were, and what you'll see is there's all this great collaboration, and this company spun off of this, and these guys created this technology together, and then this turned into this company. Really tons of great information here. And I mean, there's no possible way that I think I could cover all this in an hour type presentation. So I'm going to cover, again, a little bit of a few other things. The key things that I wanted to cover in terms of glass history is really, some of the earliest stuff here is Edward Drummond Libbey moved their factory, which the factory started, the New England Glass Company started in 1818 in New England. And he is the second to, I think his dad is the one that started that business, but they moved that business to Toledo in 1888. That's really the onset of a lot of the glass industry here in Toledo. And Libbey was a great collaborator and worked with a number of different people, but that really was the start of, I would say, the big glass exodus. The main reason he came here was because natural resources were pretty cheap. Natural gas, there were a couple different pipelines that came through the area. Natural gas was kind of a byproduct of a lot of the oil that was created, so it was really inexpensive. And then there was a good labor force and low cost, easy access to ports, a number of different things. That's probably one of the most important early onsets here. 1893, the Columbian Exposition, which is the World's Fair that was in Chicago, that was really instrumental in Toledo's history for two reasons. One is Libbey goes there and spends $250,000 of his own money to create a working glass plant in the World's Fair. It was one of the riskiest endeavors, I think there's probably ever been attempted in terms of the glass industry, but that's really what made him, is Libbey then took a big risk and it paid off pretty well. And there's, you can go into great deal on that to learn more about how that then led to the Libbey innovation. But the other thing that came out of the Columbian Exposition was the Crystal Palace. The Crystal Palace was a giant glass in the early mornings. This is again before ISO and ASTM and all these things. In the early mornings, these big glass buildings in the cold Chicago air would undergo thermal stress, and you kind of took your life into your own hands because these big shattering shards of glass would come down. And what they then did was they put chicken wire on the outside of that glass to prevent the falling glass from landing on you, which led to wire glass where the wire was actually embedded in the glass, which led to tempered glass, which led to laminated. So again, a lot of the safety innovations that came out started right there. 1897, I'll talk in more detail on the developments of the architectural glass applications, but 1903, the Owens Bottling Machine Company. This is Michael Owens. Michael Owens worked for Libbey starting back in 1888. But Michael Owens was really instrumental in developing a lot of the equipment that it took to make manufactured glass, and a lot of the Owens bottle machines. So this is the first time, instead of being hand blown, where it's machine blown, those technologies are really still used today by Owens, Illinois, by Libbey. I mean, all that really high speed, high throughput sort of stuff was really started right here in Toledo by Michael Owens, and it led to a number of different spin-offs. Owens, Illinois didn't start until 1929. And then the other last interesting one was the development of Owens Corning. And this again is Michael Owens with the Corning Corporation. They created this company called Owens Corning Fiberglass, but that company was a start off of it's during Prohibition, it's during the Depression, and nobody's buying whiskey bottles. And so they're just thinking, what do we do as a business to survive now that we're trying to make all these bottles? And they said, well, what if we just made, fused glass block? For construction was still pretty widely used at that time, and they were trying to develop a way to seal fused glass block together, and what they ended up coming up with was this really thin fibery type material that ended up turning into fiberglass. It was a competitor for steel wool, for mineral wool. But that was really a huge innovation in the company, and now that's an $8 billion industry that's locally founded that is based off of an accident trying to develop something else during World War II, Prohibition, and the Depression. So I mean, there's lots of interesting developments here. So I could go into you can speak on an hour on any one of these subjects, but I'm going to talk primarily about architectural glass development and how that's impacted buildings and designs around the country. So going back, much earlier than Toledo history, windows started getting manufactured through what's called the crown process in the 1300s. You would take a big blob of glass, you'd blow it into a ball, you'd open it up, spin it into a disc, and then you would cut rectangles out of that disc. That technology is, really early technology, dates back to the 1300s. And cylinder glass was pretty common. That was a slight derivation where you would hand blow these cylinders and just make them a little longer, and then you would cut the ends off the cylinders, and then you would split them lengthwise and open them up, and this would make what's called large cylinder glass. A lot of people, there's still cylinder glass done today through companies called Lamberts and Benheim where they hand blow this, but cylinder glass actually got turned into fairly heavy industrial manufacturing type products, where this picture on the right, you would vertically draw the ribbon or vertically draw the cylinder out of a vat of molten glass, and then you would lay that down on a big metal sheet. So you can make like 3-foot diameter, 10-foot long cylinders with this process. So a lot of people still think this was all hand blown, but this actually got really industrialized. But plate glass is really where our city starts to take off. A guy named Captain Ford started plate glass in the U.S. in Indiana in the 1870s. And then he started a company called Pittsburgh Plate Glass with a guy named Pitcairn out of Pittsburgh. And then his son, Edward Ford, actually moved to Pittsburgh or moved to Toledo. And he is the nexus of our company, which started off as the Edward Ford Plate Glass Company. And you can see there's a couple different ways that we made this product. The bottom right of this was you just take and put it on a big metal steel plate, and then you run a roller across it. This was kind of early invention. And then later on, it developed into it's like an old style washing machine, two metal rollers that you would squeegee the glass in between it onto this plate. Typically, it leaves like a diamond-like pattern on the bottom surface of that. Sometimes it was on both. So this could be sold, and it was sold as the product called rough plate glass. So when you didn't need the high visible light transparency, it would just get manufactured and sold directly. But most of this for construction was actually polished on one side and then the other. And that was because it was very optically clear, and it was one of the three key components needed for construction. And even in the 1870s, this was a very, very clear, very large sheet. We can make up to 111 by 230 inches. So 11 foot by 18 feet, even in the 1870s. You can make really, really large sheets of this. So it was all pretty interesting. But again, Rossford started, the company founder, Edward Ford, and his wife, Carolyn Ross. They merged their names to create the city of Rossford and started the company here. Groundbreaking was 1897, which is pictured on the top. And then on the bottom left is what the plant looked like. You think of industrialists that go out and develop towns. You were essentially a city builder back then. So they came to a giant field that was really essentially still a swamp at that point, filled it in, built a plant. They had to 2 miles was the closest gas line. So they had to dig 2 miles of ditches and then put piping in and then tap into the gas lines. They had to create their own wells. They had to a lot of times generate their own electricity. They had places you could get barbers, anything you possibly needed. It was a city that was built around the manufacturing, really heavy industrial manufacturing, very labor intensive. But that's how our city was founded on plate glass. And again, I mentioned there's 3 elements that you really need for skyscraper technology. You needed elevators, you needed air conditioning, and then you needed polished plate glass, because that's the only thing that was strong enough to withstand the wind loads up at these high elevations. So anything from the 1900s up until like the 1950s, 1960s was polished plate glass. So we were probably 1 in 2, 1 in 3 buildings built, were made here in Rossford, Ohio. From the 1900s to 1930s, especially. Empire State Building, Chrysler Building, Flatiron Building in New York City, a number of these really large monumental buildings all had to pretty much come out of here because this was the technology that was available. And there were really only 2 places that made it. This is just a little video of what's called the Bichoreau process. So this was a derivation as technology develops, and this is the kind of the theme you'll see throughout the rest of the presentation is, melting glass doesn't really change, but the way you form it and process it does. So that's really what we're starting to see. And you move away from these small volume, small size batch processes to more continuous, more automated, more streamlined type processes. And this was called the Bichoreau process. So essentially what they would do is these got up to be about 1,500 pots of molten glass. And they had what was called like a roundhouse to melt the different pots of glass in. Fairly large industrial to move this stuff around. It was still pretty hot and still pretty labor intensive. You would then pour this through one of those top and bottom squeegees. You typically make it about a 1/2 inch thick, maybe a little bit thinner. And it would be a continuous cast that goes on for as long as that 1,500 pounds of glass would last. And then you would polish the glass through this. So again, these processes got more and more sophisticated. Eventually they got to where it was a continuous process with continuous polishing, but this is a video, I think this is from our plant in 1926 or 1928. I actually can't confirm the date on it, but there were some pretty interesting videos that I found on done with the glass once it was manufactured. So again, you had to polish it on both sides. So what they did is they took plaster of Paris, they laid it down, and you set the glass on top of it. And the interesting thing, you see there's 7 people here to make one piece of glass. It was extremely labor intensive. I love this part of the video where this, your job was to kind of walk across and tamp it down in there. And this is so the polishers don't move around on top of the glass and scratch the glass. Instead, it actually polishes it. But 7 people make one piece of glass, and it would take 8 hours. 4 hours on one side, you flip it over, 4 hours on the other side. And in that time, it would go from a 1/2 inch thick down to about a 1/4 inch thick. So think of all the sludge and slurry and just ginormous mess. And this was also done with a polishing material that was made out of cerium oxide and rouge, which is iron oxide. So it was kind of an orangish red color, and it would be on your skin and on your clothes, and it really was just impossible to kind of clean up. As we went into more automated, the cutting process was pretty interesting. So the guy on the top here is cutting the ribbon as the ribbon moves. So you see he literally has one of those, carbide wheel tips, puts it on a stick, and then runs it across the line as the line's moving. Lots of manual offtake labor. There's no automation in the way we took it off. Fairly small pieces would tend to get cut down even for architectural sizes. And then just lots and lots of maneuvering and hand picking up and moving stuff around. Safety wasn't the utmost importance at this time, I wouldn't say. Again, you got guys picking up pieces of glass over their head, over their neck now with no PPE on. I mean, this kind of makes me cringe being a glass guy now, but that's how it was. The other thing that a lot of people don't always consider is, in the US, child labor, especially in glass and industrial manufacturing, was very common, from the 1900s all the way into the 1930s, really common. And if you go through any of those books that I mentioned, and almost all of them, they talk about, this job, with 1 man and 2 boys can do the labor of what used to be 7 men. So even as these developments happened, child labor was still fairly common. So, a lot of people kind of talk negatively about development and automation and all these sort of things, but the one positive with all these is it's actually eliminated child labor in our country for the most part, I would say, is as we get the industrialization and commercialization and automation of a lot of our processes, it allows you to then let your kids go to school, and you have higher paying jobs because they're a little bit more skilled trades that we have. So that's also a part of the journey here in Toledo. And again, I think a lot of people in the US maybe don't recognize those facts. So plate glass was pretty influential in the city. There were a ton of developments at the same time in the early 19 teens, 1906 to 1915, trying to develop other types of glass manufacturing in the forming process. And one is this process for sheet glass called the Colburn process. So, and you see in some of these old magazines, Colburn machine glass, and this picture on the bottom right shows one of these vertical ribbons. And we started a plant, and I'll show some pictures of this, in Charleston, West Virginia in 1917. Again, the development was all done for this in Toledo, but they commercialized it in Charleston, West Virginia. But the gist of the product was kind of like that cylinder glass. This top left picture is you would dip the metal bar into the furnace, and then you would draw that vertically for about 3 or 4 feet. That vertical draw allowed the glass to cool enough that you could then turn it horizontally, put it onto a roller bed, and just continuously operate it. So what this allowed you to do, this allowed you to take it directly off the production line and put it right in a window. So you no longer have to polish it. If anyone has an old house that, there's a craftsman style where they say they like the way the windows throw the light. Typically, this was sheet glass, and that's because it really revolutionized the residential world of glass. So, 1920s on, if you had a house, you almost guaranteed you're going to have sheet glass in it. A single piece of polished plate glass was 10x the price of sheet glass. It was significantly more expensive. And plate glass still had a great place in commercial buildings, but sheet glass really revolutionized the building industry in terms of housing. So this was one of our plants. This plant was a giant. It had 12 of these sheet glass lines in one building. And again, this is a city in and of itself. It had its own natural gas mine. It had its own electricity. It had its own post office. It had everything. So these are giant plants that we would build. And this is a really quick video. It's hard to see, but this is a video of this drawn vertical ribbon. The bottom of this shows the 2 pinch points that it has. It grabbed this on the sides before it was drawn vertically. and then it was fire finished is what you'll hear a lot of times. So they had fire on there to kind of minimize the surface distortion and improve the texture of it. So that was developing. There's a lot of kind of overlapping developments that happened at this time and throughout the different types of glass world. But one of the interesting things from Toledo history is Toledo actually developed the laminated glass. And if you go through the history of laminated glass, this all started with, I think it was a French scientist who had some chemicals in a beaker, and when he dropped the glass beaker, it didn't break. And it's because it made essentially like a PVB type material that held the glass together. So we eventually developed this sort of technology. We started in 1926, and then it was commercialized in 1928. And this was primarily done for the automotive market, because if you look back at Model A's and Model T's and different types of cars, they originally used plate glass. So when you got into an accident, the broken plate glass would fly into the vehicle and hit you, or you would fly out of the vehicle because seatbelts weren't a real thing, and then you could get seriously injured by just big shards of sheet glass. And so laminated glass was developed here in Toledo for the auto industry. And when it started off, it was this process that you see on the bottom right or on the far right. There were these giant pits that were filled with like a really fluid oil of sorts. So think about like pressure cooker for chicken, is you would stick the glass sandwiches down in this oil, and then you would heat it up to 300 degrees, put it at however many PSI pressure, and that's how you would cook together these laminates of windshield glass. So again, that started here in Toledo, and we've got a great history around auto development as well. But World War II for the Toledo area was a huge boom in terms of the impact that it had on innovation and design. Every plant had to help support the war effort, and we were no different. And Libbey Owens Ford, it was the company, again, Libbey Owens Ford started in 1930, but Libbey Owens Ford at the time created dozens and dozens of different technologies. So if you just look around the page here, I mean, these are bullet resistant glass, and they had optical glass that was used for, sights and for scopes and things like that. Optical glass for microscopes, tempered glass that went into some of these big spotlights that they used. The fried egg on the bottom and the left, that was a heated glazing. So we actually would take an electrical current and run it across invisible coating to heat the glass up. The top center here, we actually made glass lined fuel tanks for different types of vehicles to avoid sparks and fires and explosions in different fuel tanks. We made glass goggles that went into fighter pilots. We made a lot of the canopies. So we did plastic and glass at that time. So a lot of the canopies that went into planes were manufactured here. Even things like little mirrors that would get used for signaling, like if your plane went down and you were trying to signal another plane for help, they gave all the airmen little mirrors. Well, we made those little mirrors, and then we made all the tank on the bottom right, the little periscopes that they used to see out of there. So we made glass periscopes that got used. So I mean, this sparked dozens of different innovations and lots of different commercial companies that came out of this. So again, the innovations in terms of development of manufacturing and forming process, I wouldn't say our marketing guys were that great to come up. The best we could come up with was a product name called Paralleloplate. But essentially what we did is in the top right picture here, this is what the equipment looked like. So instead of that Bichirou process I showed you at the beginning, is as you squeegee the glass off, it's a continuous process now that goes directly into bottom and top polished glass. So continuous line that comes out, it polishes it as it comes out, and then it's immediately cut. Really, significant innovation in that it's much lower cost to make, high quality, and it's continuous, so you can continue to crank out the volume and reduce your cost. So again, a lot of overlapping technology developments, and one of them that came out of the Toledo area was the predecessor of the modern day insulated glazing unit. IGUs are not new technology. The first patents on this date back to 1865. So this is two pieces of glass with a rope that you would just tar that in place around the edge. And now that leaves you a little insulating pocket of air that would, it's like putting an extra jacket on. But the first concepts of this were actually a product called Thermopane. This was manufactured here in Toledo. Research dates back to the mid 1920s, but the first commercial product was available in the 1930s to the 1950s. We would start selling this product. And it started off with this top center picture, which is a glass to metal weld. Think of an old incandescent light bulb, how the glass goes into the metal screw. That's essentially how it was sealed. This product was really amazing. So there was a 20-year warranty on this. And if you have an old craftsman house, or if you have a picture window of any kind in like an old 1950s house and it's original, it's more than likely this technology, and it's more than likely still functioning. There's no inorganic materials, or there's no organic materials in there to break down. IGUs, and I have a couple slides on this later, there's an organic seal, a glue. That glue breaks down with time, temperature, and humidity, and then the seal fails. So when the seal fails, the coatings start to fog up, and then you get moisture in the cavity and all that sort of stuff. It wasn't really a big issue with this technology, but it got displaced because IGUs with these organic sealants are just cheaper to make. And that's what happened in the 1980s when the U.S. oil embargo came out, is they just said, well, we need to mass produce these. What's the fastest, cheapest way to make these? So that it pretty much displaced this technology at the time. But just to show you how interesting it was, Admiral Byrd, when he did the first expedition to the South Pole, took a triple glazed thermopane product and installed it in the buildings at the South Pole. And so in this, he's got 150-degree Fahrenheit temperature differential. So 75 degrees on the inside, minus 75 on the outside, and didn't have thermal stress breakage or any sort of problems. So, I mean, really, really impressive product at the time. So again, if you had a picture window in your house, it really wasn't possible before this thermopane technology. And anything up until the 1980s pretty much was a thermopane product in a picture window. And another kind of simultaneous development was glass coatings. So glass coatings, a lot of people think this is new, but again, this came out of the World War II effort. Fighter pilots would go up and their windshield would frost up, and they're trying to, look out the window to shoot at the plane in front of them. And they said, well, that's a problem. So this guy named Harold McMaster developed what's called chlorine doped tin oxide to put on the inside surface that reduces the emissivity enough so it doesn't frost up. I mean, essentially, this is the root of all low-E coatings today. And really, Harold McMaster then went on to do a number of other things and essentially use that same idea of coating technology to help develop the coatings that go into making photovoltaic cells. So, lots of different interesting technologies all right here in Toledo. And as coatings developed, this picture on the left here, this was a product called Veritran. So it's called variable transmission glass. And it was an evaporative coating. The second largest coater outside of NASA was here in Toledo. And this is a picture of the control room on this. And then eventually this developed into what's called pyrolytic coating today, which is a chemical vapor deposition, where we actually react these gases on the surface during the float process. But, low-E and coatings weren't really sophisticated back in the 60s to the 80s. This picture in the center really shows you what we were doing. All you're doing is taking regular sunglasses and you're making them tinted sunglasses. So at first we just made darker glass, and then we made darker or reflective coatings that we would put on the glass. I mean, so really pretty simple, but these were pretty major innovations at the time. But really, that's how a lot of the glass world evolved through the 60s, 70s, and 80s. And then, today, most coatings are made either pyrolytic coating, which is you react gases on the surface in that tin bath, or they're done through sputter coating, which essentially you then make the glass, you shoot electrons at a metal target, and it leaves metal and metal oxides on the surface of the glass. If you look at this picture on the right, which shows like anytime you get oil on top of water and you see that rainbow iridescence, what you're actually seeing is the oil gets thinner than a wavelength of light. And so you can then segregate the green light from the red light from the whatever light. Essentially, that's what we're doing with our coatings, is our coatings are thinner than a wavelength of light. So we're using multiple layers of coatings to manipulate the optics. So we're either, trying to reflect something, transmit it, absorb it, change the color. Essentially that's what we're doing with our coatings. So again, architectural developments from the 1950s and 60s up until the 1980s. We were still 1 in 4, 1 in 5 buildings built in the U.S. Transamerica Building, Sears Tower, the U.S. World Trade Centers, tons and tons of buildings all over. And there's a couple of buildings from Toledo here that you might be able to see while you're in town, but a lot of these were done. Some of these were actually thermopane products. So again, in the 70s and 80s, we started seeing implementation of double glazing in buildings and the Veritrain coatings in the buildings. And that's the Fifth Third Tower that's right there on the Maumee. I think it's right next to the Renaissance. So you'll actually get to see that when you come to Toledo. And then float glass. Float glass was invented in 1952 in England. The first floats came over to the US in 1959. Our floats here in Ohio, I think, were 1961 and 1963. In North Carolina in the 70s, you know, we've started implementing floats, but even up until the 1980s, polished plate glass was really what we sold. You know, it was the bulk of our sales. So when somebody tells you the float line was 1952, so a 1955 building is probably has float glass. I mean, it took 30 years to displace that technology in North America. So just because you know an invention date doesn't necessarily mean that you can carbon date what happened to a building, when it was, what materials got used. Sometimes it just takes a long time to displace these technologies because, you know, they're big markets and it's expensive to invest and create a lot of these new technologies. So, you know, it just takes time to sort of displace. So just take everything with a grain of salt when you're looking at dates and times and buildings. And then from the 60s to the 90s here in Toledo, I would say most of the development and the R&D efforts went into, you know, now that we made the glass, or now that we have these coatings, what else do we do? So you'll see a lot of things in the marketing brochures about, you know, like creating bulletproof glass or creating one-way mirror glass or doing spandrel glass or doing these glass ribs, you know, structural type glass, butt joint glazing. Vitrolite was a product that we made for quite a while, which essentially was the predecessor for spandrel glass. We would cast glass that had different types of colors to it. And what was the other one called? Vigil pane. If you look through any of our marketing materials, I'm pretty sure everybody got robbed at gunpoint in the 1970s and 80s because, you know, it kind of says you have to have bulletproof glass if you're going to have a drive-through window in your bank or a drive-through at the McDonald's or, you know, anything. It was pretty much trying to pitch that you had to do bulletproof glass, which was pretty entertaining, I thought, when I did the developments. And then I mentioned this a little bit already, but I mean, this is mostly what's sold today is these are double glazed units that are insulated glazing units. So if you look at how a product is built today, it's two panes of glass, and we refer typically to the number one surface is the outside of the building. Number two is the inside of the outer pane. There tends to be a spacer. A lot of times this is aluminum or it's stainless steel. And then those spacers most times are filled with a desiccant of some sort. So think like silica gel and that sort of stuff that you get in your packaging materials. The primary seal that's here tends to be like polyisobutylene or some sort of organic glue material. And then a secondary seal seals the edge in. Most times that's a silicone or something like that. And then the cavity is air or argon or krypton. And what that is the larger the molecule, the less stuff there is in there to do heat transfer. So an argon molecule is much bigger. And so it's a better insulator because it's just harder to do heat transfer with these big molecules. So that's how most glass is built today. And if you look at the timeline on the bottom right, you know, from the 1970s and 80s, when we essentially code switched over to say, if you put in a new building, you got to buy double glazed, and you have to put a low E in at some point to meet code. So it's taken, you know, probably 40 years to really fully saturate that market to say everything that's being purchased now is double glazed. So again, I looked through all the architectural developments and firsts. I mean, this is a very short list. And there's a bunch of other ones that are out on our website right now, but there's literally like dozens and dozens of different innovations and creations in the glass industry, even if you look just at architectural that came out of the Toledo area. So I mean, that's one of the reasons that we became known as the Glass City, because of all these innovations. So then if I look at today and I say, well, what's going on today? What's interesting? Where is the architectural market headed? What you're starting to see is a lot of pressure on the energy efficiency of buildings. And the reason that is, and this is essentially the same thing that led to double glazed low E technology becoming code, is if you look at how buildings get used today, 40% of the energy that gets used in the US goes into building operations. And of that, if you take a second level Pareto, it tends to be heating, air conditioning, and lighting. Then, that's the primary drivers of energy. And then if you look as well, like most of the U.S. building stock, 40% is double glazed. So I mean, it's a significant portion of really, really poor performing buildings. And on new buildings, the windows tend to underperform the rest of the structure. So you have like an R3 or R4 window, but you've got R10 walls, and you've got R10 or 20 walls, and you've got an R40 ceiling. Your windows, even though they're a small percentage of your overall area, they're a large contributor to your heat loss. So we're starting to see more and more pressure to say, hey, we've got to have higher performing windows. So again, now what we're getting involved with was we say, okay, well, how quickly did double glazing get developed, and how do we speed that up? Because if I look at this chart on the left, this is what's called the Ducker report. This analyzes how glass gets used for every bit of glass that's used in the U.S. So for new construction and for replacement glass, 98% of what gets spec'd goes into double glazed windows, and most of it has low E in it. But again, it took 40 years for us to get to that point. So if we want to get higher performance windows, how do we speed that up? How do we speed the innovation cycle that occurs? So that's kind of what I get involved with a lot today, is figuring out how do we kind of do some of these different technologies. And when we talk to people about windows, the things that we tend to hear about around specs is U factor. So how good of an insulator is it? The inverse of U factor is R value. So a 0.25 U factor is an R4. So lower is better. You want as low of a U factor or good insulator window as possible. Most people typically want high visible daylight. This is a scale of 0 to 1. 1 is 100% of the sun's light comes through. And SHGC is similar, but it's all about the sun's energy. So a 1 is all of the sun's energy comes into the room. And then there's different codes around the country. The northern codes tend to be, you have to have a good insulated window, but maybe it can be, not as good of an SHGC. You can let a little bit more of the sun's energy in, but in the south, SHGC typically is what drives it. Is because it's so sunny and warm, you want to make sure you're not allowing the sun and the solar loading to kind of take over and drive your energy efficiency. So that's where most of what we're doing today, and essentially the technology is the same no matter what we're doing with the glass. I mean, there's really two things that we're trying to do with the windows. So if you look on this chart on the bottom left, the sun's energy and even like long range IR and room energy, it all travels in waves, and we're essentially doing it's going to do three things. It's going to reflect off of the glass, it's going to absorb into the glass, or it's going to get transmit through the glass. And then that absorbed energy, it can actually, that absorbed energy can reflect out, or it can continue on and get transmitted through. So essentially what we're trying to do is we're trying to insulate what we want. And in the case of like the winter, what we want to do is keep the heat in the room. And in the summer, we want to keep the heat out of the room. So we're trying to design windows and coatings to be better insulators. And then in terms of filters, this chart on the bottom right says, okay, the sun's energy comes in as UV, visible, and near IR. And if you look at what we want to try to do, is we say, okay, well, we want to filter out the UV. We want to leave in all this visible daylight. We also want to keep it flat across the visible, because if you don't, that's how you start to get color from windows, especially when you look off angle. So if you don't keep it flat across there, sometimes when you look at it at a distance or at an angle, you start to get some of these wonky colors on there. And then we would want to filter out the near IR, so allow the sunlight to come in so that people get the benefits of daylight, but you don't get all the unwanted heat that comes through, and you don't get all the heat loss in the winter that happens. But what that means is 43% of the sun's energy comes in as visible daylight. So if you want something that's less than a 0.4 SHGC, you've got to reduce the daylight a little bit. So I mean, those two concepts, essentially everything that we're doing in terms of windows and window design. So we just try to manipulate those things to help people achieve the performance that they want. So if I look at what's coming, there's all sorts of different technologies out there. So there's a couple dozen that are listed on this, and I'm not going to go into great detail on any one of them. If you want, I could spend an hour on any one of these probably. But what I'm showing you is on the top left, this is what's called anti-reflective glass. So essentially what we're doing is we're reducing the amount of glare and reflectivity that you get off the glass. You can do this on one or both surfaces on a piece of glass, and you boost your transmission at the same time. So things that often gets used for is, museum cases or showcases or showrooms or press boxes, but it can also be used to actually boost your daylight. So that's something that's kind of coming that we're seeing some developments in. The picture below that, essentially what we're doing is creating a Faraday cage. So if you want privacy in your building and you want people to not be able to send out stuff on their cell phones, this is done in the Pentagon and a number of other buildings, you can actually design the glass to be fully encased and electrically charged so that it stops cell phone signals from working or allowing data transmission through the glass. You can also do the opposite and make it into an antenna and boost your transmission. So we'll see people using our technology to kind of do some different things along those lines. The bottom left picture is what's called a thin triple. So instead of just taking the traditional approach of, to make a double glaze or triple glaze, you use the three similar pieces of glass. If we use a really lightweight piece of glass in the middle, we can make an overall lightweight material, but it doubles the energy performance of that because now you have two air pockets. So we're seeing people start to develop that. To the right of that, you'll see like these two pictures. This is a 12-story building that's in Korea. And what they've done is they've actually embedded LEDs every inch throughout the glazing. So it creates all these little dots on the glass, but when you power it, you can actually turn the building into a display. So you can watch a movie, you can show your logo, you can do whatever you want. We are the coating technology that kind of enables a lot of those sort of technologies to exist. Above that, you see the transparent mirror. We see people using this hidden mirror or one-way mirrors and a lot of different technologies. The next picture above that is a guy standing next to some light bulbs. And in this case, that's where the glass and the coating get power into or out of a piece of glass. You can do it through the coatings. We've developed bird safe or bird friendly glazing to keep birds from crashing into buildings. The bottom right picture here is a solar field. We're an integral part of solar technology. We've designed coatings that actually prevent you from having viruses grow on them. The middle right picture here is what's called dynamic glazing. So instead of just making a dark sunglass, what this is powered, and it says when you want to get darker, you can get darker. So during the heat of the afternoon or the peak hours, you can reduce the light transmission and darken up that glass. It makes it more energy efficient, but it also reduces the glare, so it makes the space more usable. So we're starting to see that sort of technology really take off. And then the top right picture that's a traditional 1-inch IGU, and then stacked next to it is a 1/4-inch thick vacuum insulated glazing. So it's the same two pieces of glass, but instead of needing a 1/2-inch thick airspace, it only needs a 0.2 millimeter vacuum space in between the two. Vacuums are a really good insulator, even at a really, really thin level. So what this allows you to do is it allows you to get a similar performance from a really, really thin unit. So think of all those monolithic buildings that have single pane glass. If we can take that single pane glass out and just reglaze it using this, you can actually get higher performance than replacement windows a lot of times, but actually maintain and keep all the framing. So again, there's loads of different technologies that we're starting to develop to say, how do we solve the problems of the architectural world through our glass and glazing technology? And I think this might be my last slide, but this just shows you an example of what can be accomplished. So this is a project that we did up in Detroit called the Albert Kahn Building. Kahn's a prolific architect up in Detroit, and we tried to look at the embodied and operational carbon. So again, I mentioned that 40% of the energy used in the U.S. is in building operations, but really 1/3 of that comes from the materials themselves. So how much energy did it take to make the glass? And then how much energy does it take to heat and cool the building, that sort of thing. So what we did was we said, well, let's figure out how much energy it takes to make the glass in this particular building, just to replace the glazing. And then that operational improvement, how long does it take to pay back the embodied carbon from the glass construction? How long does it take to pay that back with the operational carbon and savings, reduced energy load, lower heating bill in the winter? The takeaway was it was a 1-month payback. It saves an operational savings in 1 month what it did to create and what it took to create that glass. So that's sort of what we're doing now is trying to teach and educate people around carbon usage and energy usage to say, let's just help design better windows and create a better space, because there's a lot of challenges out there. So that's essentially a lot of things that we're doing today. And then, the last slide that I have is just to mention, this is the International Year of Glass. We're doing quite a bit of different celebrations here in Toledo, and just trying to showcase that, glass, not just ours, but think drinking glass, think fiberglass, think all the different glass products. They create a ton of value, but they're most times invisible. People take them for granted, or they just don't really understand and see all the value that's created. So we've got all these different celebrations going around there. In September, we have what's called a Momentum Festival. It's a 3-day art, music, and glass fest. There is a exhibition that's a part of that where people take flat glass and they make interesting things. And we just brought an open house in yesterday. So we had around 700 or 800 people that actually toured our float line. And I think we've opened that up for the Heritage Ohio conference as well. If you wanted to do a tour of a float line, our plant here, again, has some original 1890s buildings, and it's how all of our glass is made today. But it's a pretty interesting process if you ever get a chance to see and learn about it. So that is it for me. Hopefully I kept on time, and hopefully it was somewhat interesting for y'all as well. But there's a lot to kind of unwrap in the Toledo glass world.
Al, thank you so much. That was absolutely fascinating. Particularly that early footage of seeing the stuff made is pretty incredible. I can't imagine the work that went into that. So we now have time for questions. Does anyone have any questions? If so, you may type them in the question box on the chat thing, I guess we'll call it. I don't know the technical name for it. Kyle, I'm curious, how did you get interested in the glass industry?
Yeah, it's a good question. So I started off as a ceramic engineer from Ohio State, and I just like math and science. It's really interesting to me. I worked in the steel industry for a while in the US, and the steel industry at the time in the 90s was really kind of felt like it was dying. It was just getting so much pressure in terms of cost and such. So glass industry seemed pretty interesting. And I just like, from an engineering standpoint, I like seeing things work and understanding it. So it was a really interesting, complex process. And then over time, I've just got more and more interested. So I tell people my title should really be glass nerd, because I just get involved in all sorts of fun glass stuff now.
Yeah. So Libby, I mean, Toledo wasn't settled until later than a lot of the rest of the country because of the Great Black Swamp, but the glass industry is one of the earliest. Would you say that it's also one of the last original industries still left in the city outside of automotive, in particular Jeep?
Yeah, so one point in 1900, Toledo was the 26th largest city in the country. Buffalo was the fifth, which kind of blows me away. But Toledo actually is a pretty good legacy history. And then like the 1970s, I want to say the S&P 500, I think like 30 companies were headquartered in Toledo. So right now I think the number is more like 12. So there has been a definite loss of other types of industry. But there's still a ton of medical stuff here. The glass industry is flourishing. I mean, there's tons of different glass industry. But there's actually, I think in the last 2 years, there have been over a dozen different companies that have brought new manufacturing plants here. So, the city's kind of going through a rebirth. It's always been pretty strong in terms of manufacturing and industrial type things, but we're continuing to see more growth. There's actually a really, really large BP refinery here. There's lots of industries that kind of service, the global glass industry, and then a lot of those technologies in terms of piping and oil and other things like that have also kind of developed out of here. So, Toledo's a pretty flourishing financial community. It's just still a small market, I would say. I think that we're still about 350,000 people.
Yeah. I'm curious, relative to Toledo and Rossford, even though the glass plant was located in Rossford, Rossford has always kind of felt like more of a blue-collar suburb of Toledo. If I remember correctly, I think even Edward Ford built his mansion in the old West End neighborhood. But then all of a sudden along the river, a lot of industrialists built their homes. Do you have any insight why Rossford never grew into like a very prosperous place such as Perrysburg or even parts of Sylvania, maybe?
Yeah, I don't know, to be honest with you. And Libby's the one that built in the old West End. Ford actually built on the river, just down the river from where the factory was. So the Ford house, I think, was only about a mile away, and I believe it is in Rossford. But part of it, I think, is due to geography because it is a little bit landlocked due to the river, and then the other
Yeah.
cities that are kind of nearby. So I don't know if that's why the development was kind of stifled there compared to other parts of the city. I really don't know, to be honest with you.
Okay. All right, we do have a question. Does Pilkington provide glass for the space industry?
Yeah, so we used to even have a division called Pilkington Aeronautics, and they would make tons of different glass that went to, was used in the space and aeronautic industries. There was actually a great ad that came out from the moon landing that we made the windows that were on the lunar module, and so there's a variety of things that came out of it. So yeah, we've got a really good history with that, but most of those companies are now spun off from what used to be Pilkington or Libbey Owens Ford, but we still are, directly tied with them. So we still sell glass into that industry, but we don't directly service that industry, let's say.
Okay, cool. Any other questions from our attendees today for Kyle?
Kyle, I had a question. How many people still in the Toledo area work in the glass industry?
That is a good question. I don't really know. I would say that locally we probably hire close to 1,000 here. We've got plant in Lucky, Ohio, which is Pemberville, 15 minutes away. We've got a plant and a fabrication plant in Rossford. We've got an R&D and finance center down in Northwood, and then we've got our headquarters in Toledo. Libbey has a factory and their headquarters here, so they probably hire another 1,500 locally, if I had to guess. Owens Corning world headquarters is here, so Owens Corning probably has more than both of us combined. They might have 2,500 people, if I had to guess. And then Owens, Illinois, their headquarters is down in Perrysburg, but they're still relatively close. I would guess in the local region, just with those companies alone, you're probably talking about 5,000 people. And then when you think about all the other kind of auxiliary or service industries that really sell directly into our industries or sell to other parts of the global industry, it's probably 3 times that. I mean, there's actually a lot of small companies that have spun out of our company and others that they go and they service the worldwide glass industry. So, I'm guessing, it's probably in the 15,000 or more range of people that kind of service directly in the glass industry. That's a good question.
Well, Kyle, random question for you. When people are in Toledo, if they want to shop Libbey Glass, is the Libbey outlet still open
It
downtown?
is, yeah, and I tell you, it's a great place to buy Christmas gifts because you can go in there and they have a bazillion different types of glass in there, and they're all really reasonably priced, I think. So it is pretty kind of fun to go look around and watch.
Yeah, it's pretty much walkable, I think, from the hotel. A good hike.
It is. There's also, like, if you're in town, there's a place called Gathered Glass in town. They do glass blowing. So that is really fun to see, and you potentially can set something up there, and that's walking distance from downtown. And then
Beautiful.
around the city, there's other places like Fire Nation, and there's a glass guild locally, and the Toledo Museum of Art is only about a mile and a half drive. So you might have to take like a scooter or an Uber or something like that. But
Yeah.
it's a world-class art museum, and the glass pavilion there and all the glass history is really spectacular. So if you've not been to that museum, I would highly recommend it as well.
Yeah, we are scheduling on Wednesday. We'll have a docent-led tour of the Glass Museum and probably the museum as well. We're still finalizing that, but should be cool. Devin, do you have any other questions?
Kyle, what you do have any upcoming events to let people know about for the International Year of Glass in Toledo?
Yeah, so next weekend is Jeep Fest. So that is, I mean, it's shocking how many people come in town to do a party around Jeep. And I'm going to be presenting at Jeep Fest, I think on the 13th or 14th, talking about the history of the development of the Jeep and the window industry for vehicles around the military and such. So that's pretty fun. It's not directly tied to International Year of Glass, but that one's good. The Momentum Weekend, that is September 15th to the 17th. It's a 3-day glass music and art festival. That Thursday, the 15th, is when we're doing, it's a gallery opening where essentially we give artists all of our glass products and help them with all the industrial technologies, lamination, water jet cutting, things that they wouldn't normally have access to. We help teach them those sort of technologies, and then they create amazing things. That gallery opening in that weekend is pretty fun, and that's a big event for International Year of Glass. There's a lecture series that's going to be going on in the fall at the Libbey House. It's an 8-part lecture series, so it's like every week there's different lectures that are there. There is a art exhibit that's opening up at the local mall, the Franklin Park Mall. I think that's August 27th. And then at Imagination Station, which is kind of the science and technology center for kids, in November, there's a glass fashion art show. So I'm not exactly sure what to expect yet, but I think it'll be pretty interesting.
Sounds interesting.
Yeah, it should be fun. And if you guys need connections or need anything else in the Toledo area, like I said, we've got a pretty wide range of connections here on, different things that are happening. And so we're happy to help with whatever we can do on that.
Great, thank you. Well, Kyle, thank you so much for a wonderful presentation. We appreciate the time and energy you put into putting this together and sharing your knowledge and history of the glass industry in Toledo. We look forward to meeting you in person in October when we're there for the conference. And I hope that our guests will come back next month, September 7th, for our next webinar presented by Partners for Sacred Places, focused on helping save or how to adaptively reuse historic churches and communities. So with that, thank you very much. Have a wonderful afternoon. The webinar will be posted in a few days on our YouTube channel. Have a great day, everyone.